Hi, I'm Jackie. This week's problem asks us to determine if this series converges or diverges. So looking at it, since there's a factorial, I'm probably going to use the ratio test. Okay, so remember the ratio test. That's the limit as n goes to infinity of a sub n plus 1 divided by a sub n, all in absolute value. So let's start writing that. So limit as n goes to infinity of a sub n plus 1. So that's this, but where it's n plus 1. So that's n minus 1 plus 1 factorial divided by n plus 1 squared. Okay, so instead of just having this massive division, I'll just multiply by the reciprocal. So then I'm going to have just normal a sub n. So that's n squared divided by n minus 1 factorial. Okay, so let's recall factorial. So n factorial equals n minus 1 factorial. So as you can see, this ends up being n factorial. So this n minus 1 is going to cancel. So let's write this over here. Limit as n goes to infinity. So this n factorial is just going to become n. And so then this goes away and we're just left with n plus 1 squared. In absolute value. So looking at this, I'm still not really sure. Maybe you have a guess, but let's be very clear. It can get annoying sometimes writing the limit and absolute value each time, but it's necessary. So don't leave them out on exams and stuff. Okay, so looking at this, it's getting more clear, but it's still not exact. So I'm going to divide everything by n squared, or multiply by 1. I'm going to get the limit as n approaches infinity. This divided by n squared just becomes n. This ends up being 1, 2 over n, 1 over n squared. So looking at this, this is very obvious, right? Because this term's going to go to 0, same with this term going to 0. So we're just going to get n, which obviously, as it goes to infinity, is going to equal infinity, which is always greater than 1. And therefore, by the ratio test, we can confirm that this series diverges. Implies diverges by ratio. Thanks for watching.